Welcome to Maths for All. I'm Aisling Flynn and this is exam practice. This is a functions question. It's from the 2014 SEC sample paper for ordinary level Leaving Cert Maths. Okay, so f of x we're given is the first function and it is 2 to the power of x, so that's an exponential function. And g of x is 9x squared minus 3x squared minus 1. That's a quadratic function. Okay, and we're asked to complete the table below and use it to draw the graphs of f and g in the domain from 0 to +3. Okay, and it's all laid out there nicely for us. Okay, so we can calculate one by one what is 2 to the power of 0, what is 2 to the power of 1, 2 to the power of 2, etc. Actually, we have intermediate steps there. We have 2 to the power of 0.5 as well. So you can do it one by one, calculating, or you can use the tables function, which I've shown you on your calculators. Okay, so that's what I'm going to use. So I'll enter 2 to the power of x for f of x and 9x minus 3x squared minus 1 for the quadratic function. Now my starting value for the domain is 0. My end value is +3, but as you can see from the table, I'm going to change the step to, instead of 1, which is in the calculator automatically, to 0.5 and press enter. Okay, and now I'll get my tables. Okay, and I'm going to transfer those into the table here. Okay, so pause, do that on your calculator and then check did you get the same answer as I've done. Okay, so when x is 0, f of x is 1, g of x is minus 1. When x is 0.5, I get 1.4, 1. Okay, I don't know how precise we need to be. We'll see later when we go to draw the graph. And 2.75. When x is 1, I get 2 and 5. When x is 1.5, I get 2.83 and 5.75. When x is 2, I get 4 and 5. When x is 2.5, I get 5.66 and 2.75. And when x is 3, I get 8 and minus 1. Okay, so check you can generate those either by calculation or by using the tables function. Alright, and our next task is to draw those graphs. So let's start with f. When x is 0, f of x is 1. Okay, when x is 0.5, f of x is 1.41, so we do our best in estimation, so just before 1.5. When x is 1, f is 2. When x is 1.5, f is 2.83, so 2.5 is there, so closer to 3. So there's an element of estimation. When x is 2, we've got 4. When x is 2.5, it's 5.66, so after halfway. And when x is 3, the value is 8. Okay, and then I will just join them up as smoothly as I can. Okay, you'll do a much nicer job. Okay, and don't forget to label. That's function f of x. Alright, so that's exponential and we expect it to start off slowly and then to rise more quickly. Now, second is our quadratic function g. So let's go through that. When x is 0, g of x is minus 1. When x is 0.5, g of x is 2.75. So there's 2, 2.5, 2.75 there. When x is 1, g has value 5. When x is 2, 1.5, g has 5.75. When x is 2, g has value 5. When x is 2.5, we're at 2.75. So here we see the symmetrical nature. We're going down just as we went up. And when x is 3, we have g is minus 1. Okay, so it's hill-shaped because we have a negative x squared term and it's symmetrical. So again, join that up as best you can, as smoothly as you can. There's my maximum, it's turning and it's going back down. And don't forget to label, that's called g of x. Okay, so that was part A. I have no marking scheme, but lots of marks go for tables and for graphs. So the vast majority of marks will be going for this first part of the question. So part B, use your graphs to estimate the value or use of x for which 2 to the power of x plus 3x squared minus 9x plus 1 equals 0. Okay, so quite a difficult equation if we're to go about it, but keywords, use your graphs. We should use our graphs. Okay, now what else do you notice about this equation? We have 2 to the power of x. Well, that was f of x. And then we have something that kind of looks like g of x. Okay, but all the signs are different. If you recall, we had a negative x squared graph, hill shape. So if you look up, we had minus 3x squared plus 9x minus 1 was the function we were given. So that in fact is minus g of x. So let me see if I can do some changing. Let's take those values from the left hand side. So leave 2 of x on the left hand side of your equation. And everything else moves to the right. Okay, when things moved over the equals, they change sign. So I'm going to write it this way because that's how it was in part A. We're going to put minus 9x becomes plus 9x on the right hand side. Okay, minus 3x squared and minus 1. Well, that's just g of x, isn't it? So the question is asking, when is f of x equal, and of course equal means the same as g of x. So when is f of x the same as g of x? And we're told to use our graphs, so we should use our graphs, and here we have it. So when are the two functions the same? And they are the same at the 2 points where they cross each other. So they're the same here and they are the same here. Okay, and we're looking for values of x, so we're looking for the x values there. So if we drop a straight line down onto the x-axis, if you remember, this was 0.5 over half, making this 0.3. Okay, if each graduation was 0.1, and over here somewhere in between, I get, that's 2.1, 2.2, I get maybe about 2.15. Okay, so my answer is when x equals 0.3 and x equals 2.15. Now you may get a slightly different answer because your graph you drew by hand, same as me, and it might be slightly different, and that is why the word estimate is used. If you're a little bit out or a little bit different, that's okay once you use your graph. Okay, and that's part B of that question. Now part C, let k be the number such that 2 to the power of k equals 6. Using your graphs or otherwise estimate g to the power of k. Okay, so we can use our graph, or we can do it otherwise, but if it says use our graph and the word estimate is used, I'd be using my graph. Okay, so firstly we're asked to find k, and here they have 2 to the power of k equals 6. Now if you remember, it was the function f of x was equal to 2 to the power of x. All right, now you see that k is taking the place of x as the power, and the outcome is 6. Okay, so what we're asked to look for is when the outcome is 6. So when the outcome is 6, what is the input? What is k? So we're going to use our graph. Okay, we're focusing now on f of x, the exponential. So when it has output of 6, outputs are on the y-axis of 6, which is here. What was the input corresponding to that? And here I found it on my graph. Okay, remember that this is 2.5. So I'm going to say that k is 2.6. Again, depending on your hand-drawn graph, you might have ever so slightly different value, and that is okay, that's allowed. Okay. Now, we're not finished yet. We've found k. Using your graph or otherwise, estimate g of k. So, what was the value of g when we're using input 2.5 or 2.6, which is k? So we can go up there, use the same input. What's the value of k? So we can go across to our vertical axis to find our output. And I get 2. I'm going to say g of 2.6 equals 2, or that's my g of k equals 2. And that's that answered. Okay, so that was a functions question from 2014 sample paper.